Good morning, students. Let me learn the topic today, Chapter 2, Polynomial. In this polynomial, we already revised a few topics in 9th standard. As we all know, that is, what is a polynomial, then what are the types of a polynomial based on the powers as well as based on the terms, right? Now, we just recall polynomial expressions based on the terms. We already know that monomial expression which has only one term, right? For example, 2x. Here, we should not bother about the powers. Only we can focus on terms. Next, binomial. Expression which has two terms is called the binomial. For example, 2x plus 3 or some other. Next, trinomial. Expression which has three terms is called the trinomial. We should not bother about here the powers, right? Are you all clear? Next, based on the powers, we should not bother a term here. Expression, a power, the highest power is 1, that is linear. The highest power in this expression is 2, that is quadratic. The highest power in this expression is 3, is called the cubic. Are you all clear? I hope you all know this. Now we enter to the polynomial. We just write a polynomial in a single variable, right? First we should know what is a polynomial, right? So polynomial is rotated as a p of x. It can be written as equal. So we know already these are all called the polynomials. So maybe it contains a 2 variable or 3 variable, but in this topic we only focus on the 1 variable polynomial. In this whole expression, in the whole polynomial, there is only 1 variable. The power can be varied, right? Next, degree of a polynomial. Degree of a polynomial. Now we should clear what is the degree, right? So degree is nothing but a highest power in this polynomial, that is a degree of a polynomial. For example, 4x power 1 plus 2. That is one expression is called as a polynomial. In this polynomial, it is a single variable polynomial, right? It is a one variable polynomial. It's based on the terms, it is a binomial. So it is no need to bother about the binomial. We can focus on the powers. Now the highest power in this polynomial is 1, right? Here it's a constant term. In this constant term, the variable power is 0, right? So the x power 0. Here the highest power is 1. Therefore, it is the degree of this polynomial is 1. It has only one variable, so it is a one variable polynomial of degree 1. Are you all clear? One more example. Here in this polynomial, what is the degree of a polynomial? The highest power is a degree. So what is the highest power? Here the power of variable is 0. Here power of variable, that is y, that is 1. Here y squared. So the highest power of in this variable is 2, that is degree 2. Next, we just consider the one more polynomial. Now the degree of a polynomial is here the highest power. Which one is highest power here? Here 3. So it is a degree is 3. These are all in a variable is x. Here only one variable, there is no other variable y, z. So it's a one variable polynomial of degree 3. Here the variable is u. The highest power is 6. So it's a polynomial in one variable u of degree 6. Next. Now 1 by x minus 1 is a polynomial or not? It's not a polynomial because in the necessary condition for the polynomial, the variable should not be in a denominator, as well as the variable should not be in a square root, right? So 1 by the variable comes under the denominator, so it will not a polynomial. Next, root of x, it is a polynomial or not? No, it's not a polynomial, because the power is here, x power is 1 by 2, so there is a only positive integers. The 1 by 2 is not a positive integer, so it is not a polynomial. Next, here as well as 1 by x squared plus 2x plus 3, so it is also the variables comes under the denominator, so it's not a polynomial. Are you all clear this? Degree is the highest power of the variable in this polynomial, that is a degree. Are you all clear? Then which one is not a polynomial? The first condition is the variable should not be belongs to the denominator, and the variable only has a positive integer in this polynomial. Then only it is considered as a polynomial, otherwise it's not a polynomial, right? It's a necessary condition for the polynomial. Next, in this polynomial we have some category wise. It can be classified by its powers, because we are learning about power, that is a degree, right? So first one is linear polynomial. The linear polynomial is a polynomial has a degree 1, it is a linear polynomial. Are you all clear? In a linear polynomial, a degree is 1. In this polynomial has the degree 1, that is called the linear. For example, 3x plus 5. Now 3x plus 5 is a polynomial or not? Yes, surely it is a polynomial, because there is no negative powers in a variable, and there is no denominator. There is no denominator. There is no variable in denominator. There is no root. There is no root values here. In variable, we shouldn't bother about the coefficients. Only we can focus on the variable. Here is the positive power. So x power 1. So the highest power in this polynomial is 1. So its degree is 1. So the degree is 1. So it is a linear polynomial. Are you all clear? Next, y plus root 2. Here we have a root 2. But it is not in a variable place. It is only the constant. So we should not bother about here. When it is a root of y, it is not a polynomial. But here the value only, the number should only the root. So what is the highest power in this polynomial? Y. The variable is y. The variable highest power is 1. So degree is 1. So it is a linear polynomial. So for example, for linear polynomial, x minus 2 by 11 is also linear polynomial, because x is only one variable linear polynomial. Here also one variable linear polynomial. Here also use only one variable, so it is a one variable linear polynomial. Are you all clear? The 2 by 3 is called at the coefficients of u. The one variable, that is a coefficient. 3 is a coefficient of z. Are you all know the coefficient, right? Okay. So in this linear polynomial, we should conclude the general form, that is ax plus b, where a and b are any real numbers. Real clear? Any numbers. It's not a real number. Maybe it's any number. So a and b are the any number. And one more condition: a should not be a 0, because when a should be a 0, 0 into x became a 0, right? So it is not a linear polynomial. We need at least one variable. That one variable degree is 1. So ax plus b is a linear polynomial general form. Next, quadratic polynomial. Obviously we know the meaning of the quadratic. The quadratic, it means square. Quadratic, it means square. So a polynomial which has the degree 2 is called the quadratic polynomial. Now for the example, 2x squared plus 3x minus 2 by 5. In this polynomial, it is a one variable polynomial or not? Because here in all the terms there is only one variable, that is x. Here x power 0. That is a constant, x power 0. So it is a one variable polynomial. Highest power in this polynomial is x power 2. So 2 is a degree of a polynomial So when the polynomial has a degree 2, that is quadratic polynomial. Are you clear, children? Next, one more example. Y squared minus 2. So here there is no, so y squared minus 2. In this y squared minus 2 term, the highest power is 2. We don't bother about the other terms. Here only focus on the powers. What is the power here? Y squared. So y squared, that is the degree is y squared minus 2. The degree is highest power. The highest power is 2. That is the degree is 2. So that is a quadratic polynomial. Even single term x squared is a quadratic polynomial. Yes, obviously it is a quadratic polynomial because we don't bother about the terms. Only we can focus on the power. Power is 2, so it is quadratic polynomial, right? Next, for examples of a quadratic polynomial, y by 3 is equal minus 2y squared plus 5. So here the highest power is 1 here, here 2. So 2, so quadratic polynomial is 2. It is a single variable polynomial. Root 5 is a coefficient. It does not belongs to the variable. So we shouldn't bother about here. So that is, root 5 is a coefficient. So it is obviously polynomial only. So y squared, so it is a quadratic polynomial. Here 4z squared. So z squared is a polynomial only, right? Are you clear? Now we can go with the general form. We can write the variable should be a power is 2. So the general form of quadratic polynomial ax squared plus bx plus c. Are you all clear? So in this ax squared plus bx plus c, b may be a 0 or c may be a 0. We no need to consider b and c. Maybe it is a 0, but the only one condition, a should not be a 0, because when a becomes a 0, the whole term becomes a 0. When the whole term becomes a 0, it's considered as a linear. It's not a quadratic. So a should not be a 0. That is a not equal to 0, where x is a variable and a, b, c are some real numbers, some coefficients, that is a real numbers. Are you all clear? Any doubt in this quadratic polynomial? So next, cubic polynomial. Obviously we know that a polynomial has a degree 3 is called the cubic polynomial. For example, x cube minus 2. So highest power in this degree is the highest power in this polynomial is degree, that is 3. So it is a degree 3 is a cubic polynomial. For example, root 3x. So these are the example for the cubic polynomials. And the general form of a cubic polynomial is ax cube plus px squared plus cx plus d. Now a should not be a 0 here, because when the a becomes a 0, there is no term. A is 0 into x cube, that is a 0. So it's considered as a quadratic polynomial. So it's not a cubic. So it is only the general form. In this general form, a should not be a 0. A not equal to 0. Are you all clear? So first we saw what is a polynomial. Based on the polynomial, we should know. In this polynomial, we should learn the degree. Basis of degree, we splitted a 3 category. That is a linear polynomial. It has a degree 1. Quadratic polynomial degree 2. Then cubic polynomial degree 3. And we saw some examples also. And we saw which are the not polynomials here also. Right? Are you all clear? Next, the most important topic is the value of the polynomial. Right? Now, when they has to given one polynomial, and they given that variable's value, we should find out the whole polynomial value. Right? For example, see here. I just consider p of x is a polynomial. Whenever they given any expression, any polynomial, should take p of x. That x should be a variable. So p of x equal to x squared minus 3x minus 4. That is the given polynomial. Now we should find out the value of the polynomial. When we find the value of the polynomial, whole polynomial, we should want the value of x. So instead of x, we can replace that value and we can get the value of a polynomial. Now here they given p of x equal to x squared minus 3x minus 4. Find the value of the polynomial when x is equal to 2. So instead of x, you can replace the value 2 and you can find the polynomial value. Are you all clear? Now we can come to the point. Solution. Put instead of x, you can replace the value 2. So x is equal to 2 in p of x. So p of that x, we can replace it as a 2 equal to, instead of x squared, 2 the whole squared, 3 into 2 minus 4. So 2 square, I know that 4, 3 2s are 6 minus 4. So 4 minus 6. So here that both are negative symbol. First we can add a negative. That is minus 10. So minus 10 plus 4 minus 6. Right? Are you all clear? Next. So P of 2 is equal to minus 6. That is the value of a polynomial when x is equal to 2. Next. The same polynomial, we just consider the same polynomial, but we should find out the same polynomial value, but when x is equal to minus 1 here, we should change into the x value. So instead of x, I can replace the minus 1. So x minus 1. In our problem, they given this. We should find out this alone, right? P of minus 1 equal to minus 1 the whole square minus 3 into, instead of minus 1, sorry, instead of x, minus 1 minus 4. So minus 1 the whole square, that is plus 1. 3 into minus 1 minus 3. Already outer side minus 1 minus should be there. So minus into minus 3 plus 3 minus 4. Next plus 1 plus 3. So that is the same symbol. So we can add it plus 4. Plus 4 here minus 4. So plus 4 minus 4, that is 0. So P of minus 1 equal to 0. So the value of a polynomial is 0 when x is equal to minus 1. Are you all clear? Now this is the value of a polynomial. Are you understood what is the value of the polynomial? When they given a polynomial, we should consider let P of x equal to that polynomial, and when they given some value for x also, instead of x we can replace the value what they given and we can substitute it and we can solve it. We can get a value of a particular polynomial when the x should be what they given. Are you all clear? Next, from this value of the polynomial, we can write the zeros of a polynomial. We should know zeros of a polynomial. Next topic. Listen. When the value of a polynomial is 0, for which value of x the polynomial is 0, the value of a polynomial is 0, that is a 0 of the polynomial. Are you all clear? When the value of a polynomial is 0, for which value of x the whole value of a polynomial is 0, that is 0 of the polynomial. Here it is the minus 6 is not equal to 0. Here instead of P of minus 1, the value of a polynomial is 0. So the zeros of a polynomial is minus 1. Are you all clear? The value of a polynomial is 0, for which value of x the polynomial is 0, that is value of a polynomial. Here minus 1 is a 0 of the polynomial. Are you all clear? Any doubt? I hope you are all clear with the value of a polynomial as well as zeros of the polynomial, right? Sure. We can go to the concept map. Now listen. First, what is a polynomial? That is P of x. In this P of x, based on the degree, we should know, we saw what is the degree. Based on the degree, we find out linear polynomial. Next, quadratic polynomial, power 1, here power 2. Next, cubic polynomial. Clear? In this polynomials, we find out value of a polynomial. From this value of a polynomial, we should learn it what is the zero of the polynomial. Are you all clear? Any doubts? Thank you.